Once again, good morning to all. So today's session, we will be discussing stratified charge engine. So this also comes in the third module. So let's see what are the objectives of today's session. So first we will discuss a brief discussion about stoichiometric ratio. What is stoichiometric ratio, its importance in IC engines. Then we will go to the concept of stratified charge engine. Then what are the method of charge stratification? And we will discuss GDI engine, comparison of GDI versus PFA engines, and CVCC engine also we will discuss. Then finally we will have the advantages and disadvantages of charge stratification. So this is today's major objectives. So what do you mean by stoichiometric ratio, air fuel ratio? What do you mean by, already you might have studied in thermodynamics. So it is the ratio of air, or that air fuel ratio which is chemically correct and which will have complete combustion. So stoichiometric ratio means it is a chemically correct air fuel ratio in which the air is just enough for complete combustion. So how will you calculate that? So that means stoichiometric ratio is the air fuel ratio for complete combustion. So then how will you calculate it for a particular fuel? So for that we have to take help from your chemistry knowledge. So just write the chemical equation of combustion. So what will be the chemical equation of combustion for any fuel? This symbol equation represents the combustion of any fuel. So you can see here any fuel is an organic compound. So that can be represented by some CXHY. And this X and Y will vary for different fuel. For petrol it will have some value, for kerosene it will have another value. So like that, this general equation represents the equation of a fuel. And combustion means we are adding air. So what will be air? Air is oxygen plus 3.76 nitrogen. So what is this 3.76? What is the importance of this number? This is because air contains, we know that air contains 21% oxygen and 79% nitrogen by volume. So that means for 1 volume of oxygen, 1 mole of oxygen, we will have 79 by 21 moles of nitrogen. So that 79 by 21 is 3.76. So this is air. This represents air. And we don't know how much air is required. So we are putting a constant A here. And what are the products for complete combustion? So complete combustion means all the carbon will be oxidized and it will form carbon dioxide, and similarly all the hydrogen will be oxidized to form water vapor. So this is BCO2 plus CH2O, and we are assuming that nitrogen will remain as inert. So it is very good assumption because the nitrous oxide will be forming only very high temperatures around 1400 degree and above. So for the time being we are assumed that this nitrogen will not take part in any reaction. So this comes as a product also. So this is a common equation for any fuel. So that means complete combustion, the product is always carbon dioxide and water vapor. So H2O. Now how will you find out this A value? Then only you can find out the stoichiometric air fuel ratio. Just to balance the atoms on both sides. So this B, you can balance first carbon atom. Then you can see this B is equal to X because only carbon atom is present here. So this B will be equal to X. Similarly, balance hydrogen atom next. You can see here Y. Left side we have Y atoms of hydrogen. Right side we have 2C. So that means C is Y by 2. Then finally balance the oxygen atom. So on the left side we have 2A and right side we have 2B plus C. So already you know what are the values of this B and C and substitute. So like that you can find out all this number of moles. So just by balancing the oxygen atom on both sides, we will get this A value. Then we can find out what is the molecular weight or mass of air by mass of fuel by using the molecular weight of air and fuel. So that is a procedure for stoichiometric ratio. Just write this equation, put the x and y value for that fuel, then balance carbon atom, find out B, balance hydrogen atom, find out C, then balance finally oxygen atom and find out A. So like that, if you calculate this for an octane, octane is C8H18, you will get the stoichiometric ratio as 15.12:1. And petrol is almost similar to octane, isooctane, heptane, etc. It's a mixture or maybe purely isooctane. So petrol, this ratio is approximated as 15:1. So that means the stoichiometric ratio for complete combustion of petrol is 15:1. So you require 15 kilogram of air for burning 1 kilogram of petrol. That is the meaning of this. You require 15 kilogram of air for complete combustion of petrol for burning 1 kilogram of petrol. So like that you can find out this for any fuel. Then what you mean by rich mixture and lean mixture? That is another important parameter we are going to use in this session. So what is rich mixture? A rich mixture which contains less than air than the stoichiometric ratio is called a rich mixture. So if the air fuel ratio is less than air is there, then that it will be rich mixture. That means fuel is more, air is less than the stoichiometric ratio. So what will be that air fuel ratio for petrol? If it is for petrol, the rich mixture will be, for example, 12:1, 10:1. So if you have 12 kilogram of air for 1 kilogram of petrol, it is a rich mixture. Similarly, if you have 10 kilogram of air for 1 kilogram of petrol, it is a rich mixture. So rich mixture, what will be the product? Any idea? It will be same. As rich mixture means it is we have insufficient air, so complete combustion will not take place. So the products we can have carbon monoxide also. So instead of carbon dioxide alone, we will have carbon monoxide. And similarly, all the atoms, hydrogen atoms will not be oxidized. So hydrogen also will present. And similarly, hydrocarbons, this hydrogen and carbon will act to form other hydro. So number of products will be there. So if it is a rich mixture, it will not be carbon dioxide and water alone. The products will have carbon monoxide, hydrogen, carbon, hydrocarbons. So a large number of chances are there. Then what do you mean by lean mixture? Yes, lean mixture is the opposite of this. If a mixture contains more air than stoichiometric ratio, we call it as a lean mixture. So more air means for petrol, it will be, for example, 17:1, 20:1. So 70 kilogram of air is there, 20 kilogram of air. So all that lean mixture. What will be the product of lean mixture? Lean mixture, carbon monoxide and hydrogen, no chance are there because we have more oxygen. So only carbon dioxide and water vapor will be there, but oxygen, excess oxygen will be there in the product. We are supplying oxygen in the excess, so excess oxygen will be there. And what is, if we have any range of this rich mixture and lean mixture for petrol? Yes, we have. That is, there is a range in which combustion in SI engine will occur, and that is 9:1 to 19:1. So in normal operation of an IC engine, particularly petrol engine, you have to keep this range. The air fuel ratio should be 9:1 between 19:1. Why it is like that? Because if the mixture is too rich, we know that incomplete combustion will take place, too many carbon monoxide, and they will finally stop combustion. And 2 lean mixture means we are supplying more air, and more air means this flame propagation. We know that in petrol engines, by the spark plug we are creating a flame, and that flame travel completes combustion. So that flame propagation will not sustain if we are giving too much of air. So that is why we are limiting this into this particular range. What is stratified charge engine? What is the idea? So we already know that the petrol engine and diesel engine have several advantages and disadvantages. For example, the petrol engine, what is the importance of charge of petrol? Petrol engine is homogeneously charged. What is the meaning of that? So petrol engine in the combustion chamber, if you have take any part of the combustion chamber, the air fuel ratio will be same. So it is homogeneously distributed. So it is a chemical air fuel ratio of petrol is homogeneously distributed everywhere in the combustion chamber. So that is why we call it as the petrol engine as a homogeneously charged engine. So petrol engine we have several advantages. For example, it is have good full load characteristics, less smoke compared to diesel engine. Petrol engine have less exhaust emissions, smoke, carbon particles, etc. High speed, petrol engine can run at high speed, and low weight than diesel engine, and flexibility, etc. So these are some advantages of petrol engine. But on the same hand, petrol engine has some disadvantages. That is, it has pure fuel economy. We know that the mileage or fuel economy of petrol is less compared to a diesel engine, and part load efficiency also less. So like that, it has some disadvantages also. And on the other hand, diesel engine which is heterogeneously charged. What is the meaning of heterogeneously charged? Diesel engine, if you take the air fuel from the combustion chamber, you can find rich mixture near the injector, because diesel engine we are using a fuel injector. So near that fuel injector, it will have rich mixture. Away from the fuel injector, we have lean mixture. So that means it is heterogeneously charged. And it has several advantages also. Good part load characteristics, good mileage, that is fuel economy. But it has the disadvantages of more weight, more emission of smoke, poor air utilization, so etc. So these things we already know. Then stratified charge engine is an attempt to combine the advantages of petrol engine and diesel engine. So this concept arises like that. So what is stratified charge engine? It is an attempt to combine the advantages of both petrol and diesel engine. Or we can say it is a midway. This engine is a midway between homogeneously charged SI engine and heterogeneously charged diesel engine. So how will you stratify an engine? So that means the engine may be petrol engine, but we are making some modification. What are the modifications we are making? In stratified charge engine, the rich mixture is concentrated around the spark plug. We know that petrol engine ignition takes place by a spark plug. In stratified charge engine, we are providing a rich mixture near the spark plug, and away from the spark plug in the combustion chamber, we will have a progressively lean mixture. So that is the idea of stratified charge engine. It is a petrol engine. Only difference is it is not homogeneously charged. We will have rich mixture, that is more fuel is there in the vicinity of spark plug, and away from the spark plug we have less fuel. It is a leaner mixture. And if you take the overall air fuel ratio of the mixture, it will be leaner than the normal petrol engine. That is the important point. So we are providing rich mixture near spark plug. Away from the mixture it becomes leaner. And overall, if you calculate the air fuel ratio at any instant, it will be leaner than normal engine. So you have to draw this figure for more understanding of stratification. So this represents the top view of the combustion chamber, all these three figures. And this is the combustion chamber represented by this circle. And this is the inlet valve. This represents the exhaust valve, and at the center you can see the spark plug. So this circle with the dot at the center of combustion chamber represents spark plug. Now you can see here this represents a rich condition of a homogeneously charged petrol engine. You have more fuel atoms. This dots represents fuel atom or molecules. So you can see here in normal SI engine in a rich condition means it will have more fuel but it will have uniformly distributed. Similarly, lean mixture means it will have less fuel but it is also Now we will discuss what are the methods of charge stratification. So according to this, the method of formation of heterogeneous mixture, it can be classified into two types. The first one is using a fuel injection only. For example, gasoline direct injection GDI engine. This is the most commonly used type of petrol engine today. And Ford combustion process engine, Texaco controlled combustion system. All these are example of charge stratification by fuel injection. So we will discuss only GDI engine. Most of them are more or less same. And another method is using carburation alone. So without any injection, using carburetor alone, we can achieve charge stratification. An example is Honda CVCC engine, Honda controlled combustion, vortex controlled combustion engine. So we will discuss each of these. First we will go for GDI engine, gasoline direct injection. So what is the importance? We can see here there is a fuel injector which injects fuel inside the cylinder of this engine. We have inlet valve, spark plug, exhaust valve, all are there. So GDI engine means during suction stroke we can see that only air is coming, just like diesel engine. Only air is swirled into the cylinder by the intake valve. So what is mean by swirl? Swirl is the orderly movement of air inside the combustion chamber. So we are creating a rotation or spinning of air, maybe by the arrangement of this intake valve or using a shrouded intake valve. So that we will study in detail next module, how the swirl is generated. So somewhere we are creating a swirl movement of air, and compression increase this air movement in the combustion stroke, and at the end of combustion stroke we are introducing a high pressure fuel through this fuel injection, and it is near the spark plug. So in this position we are injecting fuel just like diesel engine. So what will happen? The initial fuel particles coming will be carried near the spark plug by the swirling air. So already the air is moving in circles. So that will carry the first fuel particles towards the spark plug, ignite the mixture, and a flame front developed. We know that in petrol engine it is done by flame traveling. So the flame front will travel and it will help in combustion of the remaining fuel coming. So like that this combustion takes place. And overall we are using a lean mixture than the conventional engine. So the thermal efficiency is very high even at part load. And most of the modern vehicle use this GDI engine, and another important thing is they use electronically controlled GDI engines. That means an ECU or a microcontroller controls the timing and amount of fuel injection. Sensors will be there for receiving different inputs. For example, oxygen availability, vehicle speed, etc. Different sensors are used, and they will combine the signal and they will give some output signal to this fuel injection. So like that, this is a GDI engine, gasoline direct injection engine. Now what is the difference between a GDI engine and PFA engine? You might have heard PFA, port fuel injection, also MPFA engine like that. What is the difference? What is the difference of GDI engine and PFA engine. PFA engine, just look at this figure. This is a PFA engine, this is a GDI engine. So first and major difference is in PFA engine you can see the fuel injector is there in the inlet manifold. This is the inlet manifold or inlet port. And while GDI engine, the fuel injector is inside the cylinder. Just like diesel engine, it is inside the cylinder near the spark plug. So that is a major first difference. So let's see what are the difference. The first difference is the location of fuel injector or fuel spray. In PFA engine it is in the intake manifold, and GDI engine it is inside the cylinder. And another difference is what is the pressure, injection pressure used. In port fuel injection it is very less. Why it is less? Because it does not have to be that much high, because the mixing of air and fuel takes place in the inlet manifold. We have enough time for mixing the air and fuel, then only it will enter the cylinder. But in GDI engine we don't have any time for mixing of air and fuel. It should be done inside the cylinder immediately, so we have to use a very high pressure. So the pressure of fuel injection in PFA engine is very less, 40 to 60 pound per square inch. But in GDI engine it is greater than 2000 psi. That is an important difference. Then injection timing also different. In PFA engine we are injecting fuel in the suction stroke, before the suction stroke. But in GDI engine we will be injecting just like diesel engine at the end of combustion stroke only. That is just before ignition. And another difference is of course simplicity and cost. So the PFA engine is less costlier and simple, because GDI engine we have to create this much high pressure. So it requires other equipments, other plunger pump or other device for creating pressure. So we require more complex equipments for GDI engine, so it is costly. And another point is GDI engine we can use high combustion ratio. Why? Because why the combustion ratio of petrol engine is limited? We have discussed this. Because due to knocking, petrol engine if we use high combustion ratio efficiency will be more, but there is a chance of knocking increases. But GDI engine we are stratified charge engine, we are using a lean mixture overall, so the knocking chances are reduced. So here you can see the last point. In GDI engine the reduction in knocking is more, and therefore efficiency is more. So we can use high combustion ratio. Combustion ratio greater than 10:1 can be easily used in a GDI engine. But in PFA engine we are not reducing the knocking, so combustion ratio is not that much high. So these are the overall comparison of GDI engine and PFA engine. So you don't have to write this. If the stratified charge engine is asked for exam, you don't have to write this PFA engine. You have to write only the GDI engine and its concepts. This is a comparison of GDI engine and PFA engine only. Now we have come to the second method, that is an example is Horndog compound vortex controlled engine. What is this engine? This is a figure of this. This is an old concept arrived in 1976 by Honda. So here you can see we are not using any fuel injectors, but what is the difference here? So this is a charge stratification by carburation only. And you can see here the difference is here we can using a additional combustion chamber, small auxiliary combustion chamber other than this main combustion chamber. This is a main combustion chamber, this is the inlet valve, this is the exhaust valve. So this spark plug is there in the auxiliary combustion chamber, and we are using an additional intake valve. This is an additional intake valve. So an auxiliary combustion chamber is provided around the spark plug with an additional intake valve. So lean mixture, so through the carburetor we have two lines. First we will supply a lean mixture in the main combustion chamber through the main intake valve, and we will use a small amount of rich mixture to this auxiliary combustion chamber through this valve. So we are providing two types of mixture, a small amount of rich mixture here and the remaining large amount of lean mixture here. So first the rich mixture is ignited by the spark plug. The spark plug is here. So this mixture ignited. So we know a flame front develops. It travels towards this outlet of this auxiliary combustion chamber, and that will burn the remaining lean mixture. So the outlet of the auxiliary combustion chamber, where flame front travels and combustion of the remaining lean mixture takes place. So the burning takes place slowly. 2 sessions, it happens in 2 sessions, and the temperature we will keep it as relatively high for long duration, and overall the mixture will be lean. So here we are using rich, here we are using lean, but you take the overall mixture strength, it will be leaner than the normal petrol engine, and therefore we have the advantage of carbon monoxide, less hydrocarbons, etc. We are using a lean mixture. So this is the second method of charge stratification by carburation alone. Now finally we will discuss the advantages and disadvantages of charge stratification. First advantage is this engine incorporates some of the characteristics of diesel engine, so it have good part load efficiency, and knock resistance is high. We are using heterogeneously charged, so we are using a lean mixture, so the knock resistance is high. Smooth combustion compared to other engines, and we are using a lean mixture means the exhaust emissions are less carbon monoxide, less hydrocarbons, and this is another important advantage, multi-fuel capability. So we can use a low octane fuel also. So octane number is a measure of knocking tendency of petrol fuel. So we don't have to use a high octane number fuel, we can use low octane number fuel. And kerosene, even diesel also can be used. This is actually a petrol engine. Remember, this stratified charge engine is a petrol engine, but we are modifying that so that it have multi-fuel capability. Then what are the disadvantages? Yes, the main one is the power is little bit reduced for a given engine size. Because we are using a lean mixture, the power will be somewhat less. And weight also increases. We are adding an injector or we are adding an auxiliary combustion chamber. All these increase the weight of the engine, and power is reduced. So the power to weight to power ratio is more. And the last one is the manufacturing is more complex. More equipments and devices are required and costlier than conventional SI engine. So these are the advantages, but nowadays we are going with the advantages, and we already know that the carburetor is almost completely avoided in most of the higher order vehicles like 4-wheelers and above that. We will be either using this GDI engine or maybe PFA engine, etc. So with this we are ending this session. So if the examination, it may be an essay question, explain stratified charge engine, you have to first write what is the concept of stratified charge engine, then what are the methods, and you have to discuss these 2 methods, GDI engine, draw the figure, explain, then CVCC engine, draw the figure, explain, then finally this comparison of advantages and disadvantages. So thank you.